Alright, we are now compiling everything we've talked about our rational functions, standard form. Remember, we are not focusing on transformations. Okay, we're going to be finding horizontal asymptotes using those three rules we talked about. We're going to be looking for wholes, which those are factors that divide out, which we'll be looking for. And then whatever's left over after we cancel out our wholes, we'll be finding the zeros, which is when we set all the factors in the numerator equal to 0, and our vertical asymptotes is when we set all the remaining factors after we cancel out our whole in the denominator equal to 0. So why don't we get started? Which, like normal, you guys, we start with our horizontal asymptotes because they depend on the degree, which again, when we start factoring, the degree kind of gets a little bit more confusing. So might as well just knock out the horizontal asymptote while we're in our standard form. Okay, so horizontal asymptotes, remember, they depend on the degree of the numerator and the degree of the denominator. So degree of denominator. Alrighty, so the highest exponent I see in the numerator is this 2 right here. So the degree of the numerator is 2. And the highest exponent I see in the denominator, well, I don't see one, and there secretly is a 1 hiding out. So it would be a 1. So let's see here. The numerator is larger than the denominator. So when the degree of the numerator, which I'm going to abbreviate, is greater than the degree of the denominator, which case do we use in those 3 cases we talked about for horizontal asymptotes? You guys are so smart. It is no asymptote. Oh no, there will be no horizontal asymptote. No. Whoa, that P looked funky. Sorry, guys. We're sad because we like asymptotes, so no horizontal asymptote. Shucks. So this one, there will not be a horizontal line that the graph kind of gravitates toward. Unfortunately, we're super sad. Hence the sad face. Alright, now to find wholes, vertical asymptotes, and zeros, we have to factor first. So now we're switching gears to factoring, which again, you guys are confident in your factoring skills. Go ahead and factor the numerator and denominator without my help and see if you get it correctly. So the numerator, okay, we can factor it because we have a degree 2, but the denominator is a degree 1. We already wrote that. Okay, so we can't factor the denominator. So the denominator is good to go. So I'm just going to go ahead and write what we get after we factor. I'm just going to write the denominator since it can't be factored. Alright, now the numerator, we have 2 terms and we're subtracting. So the only factoring techniques that we can use is difference of squares and difference of cubes. But a difference of cubes won't work because I can't cube root of x squared and I can't cube root of 4. So this is going to be a difference of squares, which I'm going to abbreviate. Okay, so we're going to factor our x squared minus 4. Which a difference of squares says if you have 2 perfect squares subtracting, once you find the a and the c, you add them and subtract them. And then you're done. Okay? So, let's find the a and the c, which we get by square rooting the first and last term. Okay, so, sorry, things are kind of crooked. Let's see if we can fix that. Alright, so the first term is an x squared, so I'm going to square root that. And the second term, remember, you ignore the negative. Be careful. So we're going to square root the 4. The square root of x squared is x, and the square root of 4 is 2. So factored form would be, remember, we add them and subtract them. So I'm going to add my a and my c, which is x plus 2, and I'm going to subtract my a and my c, which is x minus 2. So my numerator in factored form is x plus 2, x minus 2. Yay! Alright, so now that we're in factored form, okay, now that we're up here in factored form, we are not looking back here because that will not help us to find any of this information. Alright, you guys, so wholes. We find a whole if anything in the numerator is the same as any factor in the denominator, which means they'll cancel out. We'll be chopping some factors out. We'll be disappearing. Okay, so do you spot any factors that are the same in the numerator and denominator? Holy hot dog, it is the x plus 2. Karate chop it away. Goes away. Karate chop, goes away. Okay, so that means that is where the hole is going to be. So there's a hole at x plus 2. And to find the hole, like we do everything else, we just set that thing equal to 0 and solve. Alright, so I'm going to bring the 2 to the other side, which the way we do that is by subtracting 2 on both sides. So 2 minus 2 cancels and turns to 0, and 0 minus 2 is negative 2. So there will be a hole at negative 2. So on the graph will be going, and then there will be this little hole thing at negative 2, or at negative 2 on the x-axis. So when you map it up to the graph, there will be a little hole there. So be on the lookout for that. I will be showing you a graph that has that, so be careful. Alright guys, now this is very important. Once you cancel out the hole, we never look back at this function. Never. Okay, we cross it out and we're going to write what's left over, and that's what we use to determine the vertical asymptote in the zeros. We do not look at the x plus 2 anymore. That was the hole, it went away, it's gone. So the only thing left is something in the numerator. All I have left is this x minus 2. Okay, so I'm going to write x minus 2. Alright, and since I don't have anything in the denominator, I don't need to put a denominator in my fraction. So I'm only going to be looking at this x minus 2. Alright, now vertical asymptotes, we set everything in the denominator that has an x equal to 0. But we don't have a denominator. So what do? What does this mean about our vertical asymptote? Well, guess what, you guys? This means we don't have one. Okay, we don't have one. There's not a denominator. So not only is there not a horizontal asymptote, there's not a vertical asymptote. This is like the saddest problem ever. No vertical asymptote. Oh no. So we're super, super sad. I think we need 3 sad faces for this one. No vertical asymptote. And they're all crying. And their tears all are going in the same puddle because it's super sad. So no vertical asymptote. Alright guys, and then the zeros, we set everything in the numerator equal to 0, which x minus 2 is in the numerator. This is kind of like over 1, technically. Okay, so this is the only thing in the numerator. So to find the zeros, the only thing left over after we crossed out the hole is x minus 2. So that's what I'm going to set equal to 0 for my zeros. Alright, so let's find where this thing hits the x-axis. So the way we bring negative 2 to the other side is by adding that thing on both sides. Negative 2 plus 2 cancels out and turns to 0. And 0 plus 2 is 2. So where the graph hits the x-axis is at 2. Alright, so this graph will have no horizontal asymptotes. It will have a hole at x equals negative 2, so be on the lookout for that. And it will hit the x-axis at 2. So pretty cool, right? Pretty cool. Alright, well, that's it for that problem. And guys, the next problem, example 15, is pretty much the same thing. So if you think you got the gist, I encourage you to try example 15 on your own. So go ahead and go on to example 15, and you'll be working out the final example problem of this unit. It's so sad when we work the last one. It's just so sad. It'll be okay, you guys. I'll help you get through it. I know, it's hard.